NVIDIA has in fact released with the H100, which is their, I think, still latest chip. They released the same, or more or less the same features as with the CPUs, also for the GPUs. So you have attestation and you have the runtime isolation and encryption for the GPU as well.
Hello, everyone. Welcome back to another episode. Today I have Moritz with me. Moritz is from Edgeless Cloud, a really cool company. So welcome, Moritz.
Thank you, Chris. Great to be here.
Yeah, we're happy to having you. So maybe just start very quickly. Like, who are you? What is your background? And specifically, what is this cool technology from Edgeless Edgeless Cloud Systems? Sorry, Edgeless Systems.
Edgeless Systems. Yeah, no, that's right. Who am I? I'm a German that studied computer science once in his life. Got really deep into security, computer security. Played a lot of like capture the flag competitions, and was excited about research in that area. Actually started off doing a PhD and doing research in security, more specifically like binary system security, and did a little or wanted to do a little pivot, do something outside of the research world, and stumbled upon my colleagues these days, Thomas and Felix, who were about to found a company called Edgeless Systems on the topic of confidential computing. And I had some touch points. I did a bachelor thesis in this area, where I was looking more from like the offensive side, the attacking side. But the idea of a new technology, a deep tech startup in Germany, and building some cool stuff really got me hooked. And I decided to join those two guys as the first employee. And that's where, at least for me, the story of Edgeless started. And yeah, I guess the pressing question is, what is confidential computing? What is Edgeless doing? So confidential computing is a hardware-based technology, or a term for generalizing this hardware-based technology where chips, specifically CPUs, have the ability to keep memory encrypted at runtime. I think that's the most prominent feature. And they also have a feature for doing a form of remote attestation, basically providing you with a form of verifying that this is exactly the CPU you expect to be there. Let's say, for example, this is an Intel CPU with this and that firmware that is currently running that application inside such encrypted memory environment. And these are the main two new features that the processors or the hardware vendors introduced. And confidential computing is summarizing all of the tech that builds up on these features, essentially.
Interesting. So attestation in the sense of you can actually make sure nobody exchanged the CPU against something you would not expect.
Exactly right. The CPU has a burned-in secret, and basically use that for doing signing some reports about itself, and also about what's currently running in that chip or in that system.
Got it. So it's something along the lines of secure boot, where you also have the attestation of the different stages of the boot process. Interesting.
In a sense, yes.
Exactly. But from my understanding, Edgeless Systems Constellation is a Kubernetes distribution that enables you to have like an always encrypted solution or an always encrypted container. What does always encrypted mean, and what does that give you specifically?
Right. So yeah, this is basically our take on confidential computing, is that we try to. So first of all, we see this fundamentally as a cloud technology where where there's a need for establishing trust, because you run on a shared infrastructure in a remote place. where it might be necessary, first of all, to isolate yourself against that infrastructure layer. And you want to establish some form of trust before processing any kind of sensitive data, as one example. And because it's fundamentally for us a cloud technology, our focus area or our products are in this infrastructure layer, where we want to enable cloud native applications to consume this technology. And yeah, that's basically why from the start our focus was very much on this Kubernetes cloud native application layer. And maybe with this focus of let's build these infrastructure tools, right? Let's build the shovels for the gold rush so that you can build up these cool applications that consume the technology. And yeah, as you said, our main product these days is called Constellation, which is a Kubernetes distribution specifically for confidential computing, or that specifically makes confidential computing available for your application. And we also call it an always encrypted Kubernetes for those people that are not that familiar with the term of confidential computing. Always encrypted maybe is a bit more triggering in one way. Yeah. And always encrypted means, right, when you use Kubernetes these days, you might use some CNI network interface that does encryption on the wire. You have storage that implements encryption in one place or another. And now what we add is this in between encryption during processing, the encryption in use, and thereby closing this logical gap, so that when you have a Kubernetes cluster or you have a containerized application that runs in the cloud, the data that flows through this application is encrypted through the entire time. So when it comes in, maybe over the network, it's being processed, it's being stored on disk for persistency. At all times, the data is encrypted. That's what this always encryption means.
Right. So from an applications developer or the application developer's point of view, do I need to be aware of something? Do I need to build my application slightly different? Is there something like some overhead? I think you said it's implemented in hardware, so I guess the overhead wouldn't be too big. But is there something I have to be careful about?
Right. And this is a very excellent question, because my fundamental belief is that we are very much deep down in the stack, somewhat of like a foundation, but we should be almost invisible. If we build this right, it should be almost invisible, because me as an application developer, I don't want to care about, similar to like, hopefully I don't need to care about that my storage is encrypted or there's network encryption. I just want to deploy my application and consume this. And maybe the first iteration of confidential computing technology, it was not quite there yet. Gets very technical, but essentially the first iteration, called Intel SGX, was very much process-based. So that means to do that, you would need to, or to consume that, you would need to adjust your application. You would it has some effects on the application layer. And with these later generations now, the focus is more on the virtualization layer, the hypervisor layer. So you don't isolate and process, you isolate essentially an entire VM. And this can now be applied in different ways. And with Constellation, we apply this, let's say, on the Kubernetes layer. That's why we have a Kubernetes distribution, where we isolate every Kubernetes node inside its own confidential VM. So when you deploy a container, it runs inside that confidential VM. The memory of that container during processing is automatically encrypted. And we do some of course, some more tricks and treats in different layers, so that not only is the memory encrypted, but we can also make use of this attestation feature, so that in the end, when you create a Constellation cluster, you can do some meaningful verification about this is indeed a benign Constellation cluster that has integrity, that when I deploy my application, I know I have this runtime environment that is isolated from the cloud, and fundamentally the cloud provider, which is probably the most important feature. So yeah, as an application developer, I don't really need to take care. For me, it's just any other Kubernetes. In fact, it's CNCF certified in the sense that it fulfills the CNCF Kubernetes conformance tests, which is not surprising because even though we are a Kubernetes distribution, we don't modify the Kubernetes itself, right? Inside our confidential VMs, inside the isolated environment, there are the vanilla Kubernetes components running. So we run the actual release artifacts from the Kubernetes project itself. So it's not surprising that we fulfill that in that sense. But yeah,
So that means you are a CNCF certified Kubernetes distribution, which I think is important for many people that actually need to run their own Kubernetes clusters. And that makes total sense. Yeah. When I install that, do I install it in a cloud, in a private cloud, on-prem, anything?
Yeah. I mean, the goal here is, of course, anything. There are multiple arguments for Kubernetes, or strong points for multiple Kubernetes distributions. For us, of course, it's the confidential computing aspect. So the primary focus is public cloud. Currently, you can go through the 3 hyperscalers and you can create Constellation clusters. What needs to be there is this hardware layer. You need the hardware features, and you need to have them exposed so that we can consume them, create our confidential computing environments, and we have that on the hyperscalers. You can, of course, also do that on-prem. There might be different reasons to do so. It's not the typical cloud case then, I guess, but yeah, you can do that as well. And this is, I guess, where the most touch points are with Constellation. So the actual handling of the Kubernetes distribution. And you can use Constellation standalone, but I think, yeah, that's probably one of the more interesting points in terms of any kind of compromises you have to do. So we try to make your life as easy as possible, and we don't get around having our own distribution due to the fact that this should be an isolated environment. It's not straightforward to offer this in a managed way. So one thing, of course, is integrations like Terraform, infrastructure as code. So you can plug and play that into your code bases. And other directions are integrations like I would call them matter orchestrators, like let's say a SUSE Rancher, or there might be others out there. And of course, integrations into these kind of toolings are also something we strive towards, but we're not quite there yet. No.
Right. So you said in cloud providers, I guess you can deploy it from marketplaces as the easiest solution.
Yes, marketplaces is the easiest way, and it also offers us to provide this in a dynamically built way, right? So you get automatically built for only as much as you consume.
Right. And you also mentioned that you need to make sure that the hardware is, or the hardware capability is actually exposed. I think for when you use the marketplace installation, that's probably easy because you only provide or only offer the different options that are available. But are there like older instances where this capability is not available, or older systems? Or is that something which is slowly fading away and it's not going to be an issue in the next month or so?
No. So yeah, currently not all machine types have that feature available. It's still relatively new. But I'd say, like, for AMD, the latest generation exists, I think, since the last 2 generations. With Intel, it's being rolled out with the last generation. So it's something that will with the upcoming releases probably be available in almost all instance types. But as of now, there are specific instance types. You need to select those instance types for creating the cluster. Sure, as you said, marketplace makes this straightforward. Depending on the client-side tooling, it's also fairly simple, or of course well documented also by the cloud providers. Yeah.
Right. Just in case somebody, I don't know how broadly this is used right now. You mentioned AMD and Intel. Is ARM supported yet?
Yeah, that's no, that's a great question. And ARM is something people, of course, ask a lot. So there is an ARM specification for confidential computing called the CCA, the Confidential Computing Architecture. So far, it was not released as silicon. So the specification is out. Nobody has licensed and built a chip based on that. But very interestingly, there will be, so we will organize a online conference next week for confidential computing called the OC3. And there will be a big talk from about ARM and ARM CCA from mostly ARM folks, and I believe some not sure, maybe some from some cloud providers or something. And they will present the current status and when things are getting started with silicon. So yeah, if that's an interesting topic for some listeners, might be interesting to listen into this talk at the OC3, which is free for sign up. You can
perfect.
find it in oc3.
Well, we'll put it in the we'll put it in the notes. People will find it. Yeah. It's awesome. Always easier to just give somebody a link.
Yeah, for sure.
that is actually interesting. I think I have to sign up myself. That sounds really interesting. I've done a little bit in like secure computing for embedded devices in the past. That's why I know the attestation for secure boot and similar systems. So that is certainly something along my lines as well. All right. Let me see. What do you think is like the most important trend right now when you look at something like Kubernetes as a whole, or specifically like the computing space or the secure computing space you're in?
Yeah, very good question. I think this space has so much velocity that so many things are happening. One thing I would definitely see is that all of this AI, generative AI, large language model thing is not passing us entirely. I think it's hitting us full front in all kinds of capacities. But of course, we also get asked, okay, now what about confidential computing in terms of AI, in terms of GPUs? Because there's a very interesting use case, right? All of these people want to consume things like ChatGPT, but do you provide all of your data to ChatGPT? Maybe in your personal life, but can you do that in an enterprise context? What about like the public sector? And yeah, lots of questions, and that's where we see a lot of things getting are moving. NVIDIA has in fact released with the H100, which is their I think still latest chip. They released the same, or more or less the same features as with the CPUs, also for the GPUs. So you have attestation and you have the runtime isolation and encryption for the GPU as well. So yeah, that's something where we are very busy with. How can we make that available to workloads? So that you can, let's say you can build a confidential ChatGPT to say it in very broad terms. But yeah, that's definitely something. And I believe this is just my view, but the whole AI space is also super interesting for the cloud.
I think that makes a lot of sense. Especially because you said, right, if you need to analyze those data, do you want to have it encrypted everywhere except for when you actually process it? But on the other hand, it's interesting that you said AMD has it in their CPUs for a long time, but it seems nobody thought about the graphics cards yet. Right? It's interesting.
Yeah. No, for sure.
So one last question, because we're already running out of time. Like, what do you think is like the most overlooked workload or a type of workload when you move to the cloud? Or what do you think is mostly overlooked in workloads? Let's put it that way. And don't say encryption, because that's obvious.
No, I mean this is a very difficult question. Probably there are a lot of things you could name here. I could give so many philosophical answers here. No, but I think one thing I see right now when we talk about cloud migration and stuff, we are very much at this infrastructure layer. We are very much at this, let's say, the original layer still of cloud. Whereas if we look at the cloud providers, we're already talking about like PaaS services, of course, SaaS services. Everything can be consumed in a managed way, and yeah, I believe there's a very interesting discussions in the area. Where do I want to go in that range, right? Where do I want to use plain infrastructure service? Do I want to use as much managed as possible because it reduces the cost I need on my side in terms of expertise, in terms of building stuff, in terms of cost? I don't know, but also I lose maybe a bit of control. I lose maybe a bit of in-house knowledge. That's definitely an interesting I don't know, triangle where moving in one direction or the other has certain implications on the other side.
All right. Yeah. That was fun. As I said, we're unfortunately out of time again.
Yeah.
It's 20 minutes is so short. Anything else you want to add on that? Anything you feel you have to give away?
No, I hope maybe some listener found this insightful. I can just repeat myself, the OC3. If you're interested in the topic, I think that's a good place to start. Get a broad overview from all of different players, like cloud providers, open source vendors, as we are, hardware vendors. Lots of stuff to explore.
Awesome. We'll put your contact details in the show notes. I am not sure if it will be out before the OC3.
Okay. Yeah. If not, everything will be recorded and on YouTube. Still probably a good place to start.
Yeah,
but yeah, good point.
I wanted to say, if somebody wants to meet you and talk to you about it, but you're probably being at different conferences, and as I said, we put contact details for you, so people can just write you a mail or ask any question. All right.
Okay.
Thank you very much. It was lovely having you. I still have a lot of questions. You may have to come back at some point.
No, thank you very much for having me. Was great chatting.
All right. Thank you very much, people. Looking forward to see you next week. And we'll see you again.